Hello, this is Jack Jackson. In this video, we're going to program in an inverse geometric probability program for the TI-84. And what we're doing is we're trying to solve problems of the type probability of x less than or equal to a equals c, where the probabilities come from a geometric probability distribution. And it turns out, as we've seen in an earlier video, that this we can solve for a, and we get this formula. A is the natural log of 1 minus c over 1 minus p, where we know the c value. Of course, we know the probability of success p, and we could use this formula to find the a. Now, unfortunately, that a value is not necessarily a whole number, and it needs to be a whole number to actually work out the probability of that a. So what we're going to end up doing is rounding that up or down as needed to find the particular a value we want. So what we're going to do is we're going to write a program, and it's going to output actually a matrix that's going to be basically like a little bit of a table for the relevant part of a geometric CDF. We're actually going to do it where it has 3 x values and there are 3 corresponding CDF values. Okay, and if let's go ahead and see how to do this. So let's pull up a TI-84 and let's clear this out and start fresh. So we're going to go to Program. I have another program in there earlier, so we're going to create a new program. Okay, and we're going to put this in and hopefully get it all in there well. So it's in alpha lock now. We name it. I want to name this program INV for inverse, and then GEO for geometric. GEO, G, see the letters are above here, E, O, like that. Hit enter. So that's going to be the name of the program. Now the first thing it's going to ask us to do is we need to know the P and the C are the 2 numbers it needs to ask us for. So we're going to do that first. So we're going to go to Program, and you go to Input Output, IO, and we're going to put Display, which is number 3. And we're going to display some text. I'm going to put it in alpha lock by second alpha. Start with a quote. And I'm going to type in probability of a success. P R O B A B I L I T Y. Space is down here on the 0, on the O. Yeah, the 0. Probability O is actually up here, O by the 7. OF. And that looks like that's about all it's going to fit on one line. So quote. Go to another one, display on the next line. Number 3 of, yeah, we can do this. This will work. Alpha lock. Oops. Alpha lock. Quote. Success. S. U. C. C. E. S. S. Success. Yeah, that's right. Success. That's on each trial. So enter. And it's going to recall that P. So then we go to Program. IO. Prompt, which is number 2. Prompt for alpha P. So when we run this, it's going to type on the screen probability of success, and then P question mark, and the user will enter the value of P. And we're going to assume the user knows that he's supposed to enter a value between 0 and 1. Okay, next we're going to have to enter the cumulative probability. Okay, so we'll do the same thing. So Program IO, display 3, alpha lock, quote, cumulative probability. UL. Now, if you have a better way to phrase this, then by all means you can phrase it like you want, because it's just displaying this text on the screen. This is the way I'm going to do it. Okay, cumulative probability, and now we're going to prompt us for number 2, and we're going to call that value C. So if you want the rest of this to work, you need to use these letters P and C. If you want to change them to something else, that's fine, but I'm going to use P and C for the standard number for P, for the letter P for the probability of success each trial on a geometric, and C as the cumulative probability that we're looking for. Now we're going to solve for this. We're basically using this formula right here. So now I'm going to use this formula right here and figure out A. So that's natural logarithm of 1 minus C. Now C's already been entered, so this makes sense. Divided by the natural log of 1 minus P, which has also been entered. So this makes sense. I'm going to store that as A. All right, now I want to round this down, so I want to go to number, math, right arrow to number, and go to, let's go to integer part of A and store that back as A for the moment. Actually, I'm gonna do one more thing. So I'm going to take the integer part of A. What that does is it takes the decimal part and just throws it away. So since this is a positive number, that's just rounding it down. And I want to go even one lower, so I want to take that and subtract 1 and store that as A. So this should go actually one lower than we really need. Now the problem is that it may have gone too far, because this number might be 0 or might be a negative, and that's no good for a geometric. Geometric can't go below 1. So let's make sure it doesn't go below 1. So math number 7, max. Maximum of either 1 or A, whichever one of those is biggest, and that's going to be my new A. So I've changed A a few times here. So A gives us basically this A here, rounded down 1, and then 1 below that, but then make sure we don't go below 1. And that gives us a starting A. And we're going to use actually 3 different X values. We're going to use this A, one bigger than this A, and one bigger than that. So we're going to go 3 consecutive A values, and we're going to make a matrix which has those in it for the X's, and then for the Y's are going to be the CDFs of those particular values. Now this matrix needs to have 3 rows and 2 columns. So we need to make a 3 by 2 matrix. Now the way you make sure your matrix is the right size is you put a curly brace like this, and then put in 3 rows, 2 columns like that, 3, 2, in your curly brace, and we want to hit the store key. We want to store that in the dimension of the matrix. So that's under matrix here. Under matrix, and go to dimension. So that was, see I arrowed over to math. Number 3, dimension. And then we go to matrix A. Now by the way, it may look right if you just type bracket A bracket, but it will not work right. You have to get matrix A by going under matrix. If you noticed, maybe I did that too fast, but if you notice, I went under second and right here to get matrix, and it was the first one. So matrix A is going to hold our answer. So matrix A is essentially going to be our little portion of a CDF table. So now we've made sure that that matrix has 3 rows and 2 columns. Now here's what we're going to do. We're going to work this out for each one. So we're going to take A and store it in matrix A. A and matrix A are 2 different things. And we're going to store it in the first row, first column. Then we're going to do the geometric distribution here. So now we go to distribution and go to geometric CDF. Okay, and we want the probability, we don't know what it is. It's going to be a variable, so it's going to be alpha P, whatever stored before for P. And the X value is going to be whatever A is. And let's paste that in there, or if you have the older one, it's just geometric CDF PA. And we're going to store that in our matrix, like that, matrix A. And we're going to store that in the first row, second column. Now I'm going to take A plus 1, whatever A is, I'm going to didn't mean to do that. Okay, I want to take alpha A. There we go. A. Add 1 to it. Store that in matrix A. Okay, and that is the second row, first column. And for the second row, second column, I need the CDF of that A. Now remember, this is a, go to distributions. This is a geometric CDF, and the probability is still P. The value this time is A plus 1 more. And I can paste that in there. And I want to store that in matrix A and give it, let's see, where are we? We're up to the second row, second column. We're going to do it one more time. So we're going to take alpha A plus 2, store that in second here matrix, choose 1, that's A, third row, first column. Okay, and then we'll do the CDF of it in its corresponding second column. So go to here. This is good. Change this to A plus 2. Paste that in. And that's stored in matrix A. Third row, second column. All right, hopefully I've done this correctly. Now all I have to do is display my answer, which is program display. Let's actually display a little bit of text to go with it so it helps the user out. X, comma, CDF of X. So hopefully they can remember that that's what we're looking at. What do you say we actually just insert parentheses around it so it looks like an order pair, which is of course what it is. So that text will show up on the screen, and now after that we want it to actually display the matrix. So number 3, display matrix A. Alright, that should be done. If we quit, it will save it automatically. Alright, let's see if I can run this and see how it runs. So program, go to number 2, execute, enter. Probability of success, let's say it's 0.3, and the cumulative probability is, say, 0.9. Uh-oh, have a problem. Let's see if we can fix it. Oh, somehow that didn't there's an extra quote there that I didn't mean for it there to be. Okay, try again. Notice it took it to me, so I can go back here. Let's run it again. Let's see if this works back. Okay, let's say this time the probability of success is 0.3, cumulative probability is 0.9. If we've done this right, we should see a little portion of a table, X and CDF of X right here. And there is 9, there's the cumulative probability, 10, cumulative probability, and 11. Usually it's the last 2 numbers that we're interested in. 11 will be, if we get to 11, we have a cumulative probability of 0.914. That's the first time it actually goes above 90%, is when X is 11. And right before it goes above 90% is at 10, where the probability is 0.8926, just slightly below 90%, whereas at 11 it's slightly above 90%. Depending on the context of the problem, you might need the 10 or the 11, depending on what you're doing with it. But you can see both the 10 and 11, and you can see their probabilities right there. Here I ran it in the program that I wrote in the previous video for the, or the function I wrote for the Inspire, and it looks like I'm getting the same answers, so I feel pretty good that we've not made any errors here, that this is correct.